Are you okay?
What year is it?
21. Who are you?
PD 1000. I need your help to save the world from global warming.
Sure?
Come with me.
Okay. I thought you were riding cool motorbikes.
No, motorbikes and cars release too much CO2. Public transport is the best.
So what exactly are you saving the world from?
In my future, the world is destroyed due to CO2 emissions. I'm here to show the world the power of renewable energy.
How would you do that?
This thing, an MFC 2000, a microbial fuel cell.
Is it dangerous?
Not at all. It uses bacteria to catalyze the reaction to produce electricity. I need you to sell it to a bunch of business people. But first, we need to distract the salesperson. Will you help me? There he is, right there.
This is a public announcement. Any goods from getting to the convention center must board the train leaving platform 3.
Wow, that's exactly my address.
That was easy.
I'll tell you the rest on the train. Let's go. Today, our group will be discussing about microbial fuel cells, or MFCs, which can produce electricity and treat organic waste simultaneously. Currently, there is research developing on the ability of the electrode-associated microbes to degrade wastes and toxic chemicals. The main applications of MFCs are electricity generation, waste treatment, BOD sensors, powering underwater monitoring equipment and remote sensors, and hydrogen production. And on the right, we have an MFC diagram. So you can see the anode, cathode, the membrane separator, and the resistor, and the bacteria. And on the bottom, we just have an example of one of the bacteria we can use, Geobacter.
The catalytic activity of a microbial fuel cell can be determined by measuring the current generated at the cathode using an ammeter. On the scheme here, there is a typical fuel cell operating with acetate as electron donor and Geobacter sulfurescens as anodic bacteria. The microbial fuel cell activity is characterized by power and voltage curves, showing how the voltage and power vary with the current, which is expressed on our graph here, showing the relationship between current voltage and current power in MFC. Acetate is the preferred substrate to use in the anode.
So in MFCs, electron transfer is implemented via extracellular electron transfer, and basically conductive nanowires consisting of 4 P-line proteins transfer electrons to extracellular electron acceptors. And the half-cell reactions, for example, with acetate as the electron donor in an air cathode system is given below. So at the anode, acetate reacts with hydrogen ions and water to form CO2 and more hydrogen ions and electrons. These electrons are then transferred through a wire and resistor to the cathode, and the hydrogen ions diffuse across the proton exchange membrane. And at the cathode, they react with the oxygen to form water. And then below is the net cell reaction. And using Nernst's equations and the Gibbs free energy value of the cell reaction, we can find a theoretical voltage for MFC using a specific substrate.
Okay. The activity of the catalyst is limited by several factors. At high rates of current flow, it's limited by transport of ionic species through the medium, as well as transport of donors and acceptors to the electrode surface. At low rates of current flow, the activity is limited by the rate of charge transfer at the electrode surface. pH and temperature are also the factors limiting the activity of the catalyst. Next, please.
So we can improve our MFC by designing better cathodes out of better metals or metal alloys to speed up the oxygen reduction reaction. We can genetically modify the bacteria so that they're more better and efficient at transferring electrons, and we can co-culture multiple bacteria together to positively affect the joint performance of the MFC. And on the right, we just have an example of the nanowires. So we found that the studies are often rate sensitive. MFCs have quite low efficiencies, but there are plenty of bacteria, specifically electrochemically active bacteria, such as geobacter and other species we can use, and plenty of organic wastes we can use to power the MFC.
That concludes our presentation. Thank you for watching and have a nice day.
What the hell are you two doing here?
Presenting an alternative to coal, MFC 2000.
That's impossible. Coal is not replaceable.
Not with this attitude.
Kid's got a point, but with enough innovation and effort, we can overcome this. How much waste does coal produce again?
Well, the numbers vary.
Ours can produce electricity from waste.
Damn. Not gonna lie, that sounds pretty cool. Tell me more about it.
We're presenting about MFC 2000.
Fuck. That's impossible. Core is irreplaceable.
We messed up the line.